Hey guys, what's up? In this episode, we are going to talk about filters. So, what are filters? It is basically trying to enhance a portion of an image with respect to other section of that image. So, you have your cell phone where you have different photo editing tools, and where you get the option to apply some filters, which is give some cool effects to your image. So, the this is the this is the episode where you get to learn how can you create your own filters. Now, filters is about applying convolution using a kernel. Now, what is a kernel? Kernel is something, a patch, or a patch of a small patch of a pattern that you are going to apply to every section of your uh, input image. So I have a kernel here. So it's a 4 by 4 kernel which has all the zeros. What we will do, we are just going to apply this kernel in each and every section of your image. So imagine this is your image, and this is like a, imagine this is a cut down version of your image which has only 5 by 9, 5 cross 9 pixels. Means just a you just cut a section of an image, and I'm just presenting it here. Now if I want to apply convolution using this kernel over here, then I'm going to first place my kernel on top of a section of that image where it fits, and then I'm going to multiply each and every cell with its corresponding overlapping image cell or image pixel. Then once I have multiplied each and every cell with its overlapped image cell, then I'm going to sum them together and get a value. That value is something that we are going to put in the center of that output image. So this is what a convolution is. Let me put do I say I'll put a table here. I don't need this much. So let's do a let's put one here. Okay, and let, let's make it one. So this kernel has all the ones. So if I apply it, uh, let's make the kernel 3 by 3 instead of 4, then we'll get a center pixel. I'll delete this row, this column, and we'll also delete this row. So we will have one 3 cross 3 kernel, and if I apply it here, so we will get the value as 33 uh, plus 33. I can make an equals here. 33 plus 33 plus 180 plus 33 plus 33 plus 180, and again it will repeat. Basically it will repeat 33, 33, and 183 times. Let's do that. Plus 180, and whatever the value that we get, we'll put it in the center of that patch. So we are getting 738, so we will put 738 in our output image. Let's duplicate this, and we get our output image. Output image. So output will have, we will have 738 here. But now you can see that our output image is exceeding the our boundary, which is bound by boundary I mean the maximum pixel value, which is 255. To make that work, we have to divide our output with the total amount of multiplication that we are doing. So we are multiplying, the sum of our kernel is 111, and we have 9 cells, so it is 9. We will going to divide the output with the value 9. So this is like normalizing the output. So it is 82, so our value will be 82 here. Now you can see, if you see this part, we have took we have taken the kernel and overlapped it and did a convolution on top of it, and the center pixel will get the value of the convolution, which is 82. So what we are going to do, we are going to do the same thing for all the other pixel. If I slide down the kernel to next pixel down, then we are going to do the same thing again, and we will get a value 82 again, because it's the same thing if you do the calculation. So all the center cells will have the same value. Now if we, let's go one cell left or right, sorry, then we will have 80, 180, 180. How many times we get? 6 times 180 and 3 times 33. So the value will be 33 multiplied by 33 plus 180 times 6. Total we will divide it by 9. Then equals, the value is 131. Let's write it down here, and we were going to do it again after this pixel. So these are all 180. So if we do the math, we divide 180, sorry, we multiply 1 with 180 how many times? 9 times, and divide by 9, it will be 180. So same goes for all these below because of the symmetry we have here. Now if I imagine the image is going same way, so because we don't have the other section of the image, I'm not able to apply it further this. But imagine we have cells here, and we are able to apply our convolution, or it is going to continue with 180, then we are going to get 180 at the end as well. So let's do this. And if 33 is in this side, let's say we have a cell, or let's insert a cell here, insert a column before, and let's make it 33. And if we apply our convolution here, we will get 33 here. Let's do the entire thing. And if we think that our image is going beyond on top, then we will have the same thing on the top. So now this was our input image, and this is our output image. So if you notice this, the input image has a sharp increase in the pixel, where our output image has slowly increasing the value. So what is happening here? This is something that we have already seen. This is blurring. So we are, this is, if you think of this side, it's a very sharp edge, where this is something that is smoothly increasing in a regular fashion, in a slowly increasing fashion. So this is, this kernel, if we apply it in any image, this will blur the image. Now similar way we can apply some other kernels. Like if we want to detect edges, so we have different kernels for that. So I will going to show you one of the kernel, which is shovel for horizontal line detection. uh, we have 0 0 0. So if we apply this kernel to any image, so it will automatically detect horizontal lines. So basically, so that's all for kernels and convolution filters. Let's apply this in our Python code.